In the given question, it is asked to find a force required to move a block of weight 350 newtons horizontally, and the coefficient of friction between the body and the plane is 0.23. Weight of the block is 350 newtons and mu is given as 0.323 newton 0.23. The line of action of the force is inclined upwards at an angle of 50 degrees with horizontal. So we are supposed to move the block along this horizontal plane. Let's say this is the horizontal plane, and on it a block is resting. So the coefficient of friction is given, and the force applied on the block is making an angle of 50 degrees with the horizontal. Let's say this is the force P, and this force P is going to make an angle of 50 degrees with horizontal. Let's say this is the reference axis, and let us call this angle to be as 50 degrees. And so now the vertical component of this force will be P sine 50, and the horizontal would be P cos 50. And if we plot the free body diagram, the easiest one is the weight of the block, which is acting vertically down. This would be weight of the block, and due to the contact between the horizontal surface and the block, there will be a normal reaction. The normal reaction will be collinear with the force or with the weight, and it will be acting upwards, and along with the normal reaction there will be an additional force that is going to be accompanied. So in the question we find that coefficient of friction is given. So with the coefficient of friction, the additional force that has to be taken into account would be frictional force, and that is going to oppose the motion. So frictional force, generally we write it with lower that is F in lowercase, and F is equal to mu times of Rn. So now we need to consider the equilibrium of forces in the x as well as in y direction. So sigma Fx equal to 0, that is P cos 50 is equal to F, that is rightward force is equal to leftward force. So P cos 50 is equal to mu times of Rn, and Rn here would be equal to P cos 50 divided by 0.23. Now we need to consider the equilibrium of forces in the y direction, that is sigma Fy is equal to 0, that is Rn plus P sine 50 is equal to W. Summation of upward forces is equal to downward forces. So now we have, in the equation 1 we have expressed Rn in terms of P. So we can put that in the second equation. So that is P cos 50 divided by 0.23 plus P sine 50 is equal to W, that is 350 newtons. So now we can pull out P as common and write here as cos 50 by 0.23 plus sine 50 is equal to 350. So if we simplify this further, this becomes 350 divided by cos 50 by 0.23 plus sine 50, it would be and this upon solving we would get as 98.29 newtons. So here I want to conclude a point in the problem, that is, whenever there is a contact between the bodies, there has to be a constraint. Contact basically is meant to constrain the body or constrain the motion of the body in that direction. So here the contact is between the block and the horizontal surface, which means the body is restricted to move in y direction. Because of this contact, the body is restricted to move in the y direction. Here we can maintain the contact and we need to move the body. So when you maintain the contact, then the body cannot move in the y direction. So when there is no motion in y direction, it is going to induce a reaction force in the y direction. Same way, there will be another force, that is friction force, it will be accompanying. So here we can see that the body is free to move in the x direction. So the force which opposes the motion, which causes somewhat resistance in the motion, okay, and that is called as friction force. So friction force is not going to constrain the body fully, remember that, but the reaction force is definitely going to provide more constraint. Okay, so please remember the sequence here. When there is a contact, there is definitely going to be a normal reaction, and at that contact, if the body is tending to move, the friction force will be present.